So today's experiment is dielectric constant of non-polar liquids. The experiment is very simple. Taking the readings is very simple. The apparatus required are the capacitor, capacitance meter, and transformer oil. This is the capacitor over here. In this beaker, oil will be provided, and this is the capacitance meter. So in order to find the dielectric constant for the oil, we are going to use the concept of parallel capacitance in parallel. The concept is that the oil and the air in the tube are in parallel, and hence we'll be using this formula over here, where C is equal to K1 epsilon naught A1 by D plus K2 epsilon naught A2 by D, where A1 A2 are the area with respect to air and oil, and D is the distance between the two. All of this will be given over here, or you can take a note of it. And A1 is the area with respect to air column. So when there is nothing over here in the beaker, or when this is not submerged in anything, that's the length of the air column. In this case, it's 120 mm, and A2 is the in A2 the L2 is the the distance of the oil, how much it has submerged in oil, and hence we find the A1 A2, and then we simplify this formula to get K2 is equal to some value, which is the value which we are finding out. Okay. Now, so in order to start the experiment, what we'll do is basically connect this capacitance meter to the circuit, and we make sure that this capacitor is very straight to the beaker. Make sure, okay, you can change you can make it straight by loosening this and rotating, or try to make it straight. And this screw over here makes it go up and down. Now, in order to take the reading, what we do is just click this measure button, and it will measure it for us automatically. So in this case, it's 89 picofarad. So our capacitance for air is 89 picofarad. So we are going to perform the same thing for different lengths of L1, different lengths of the oil column, by submersing it by 5 millimeters. And so in order to estimate the dielectric constant, we are going to vary the length of the air column or the oil column by submerging the capacitance in the oil very slowly by 5 millimeters, and then correspondingly we will take the readings. So for each submersion we are doing 3 trials, and then we take the mean value of C, and using that C value we substitute in the formula over here, and then we find the dielectric constant. We do this for 10 trials, and at the end we take the mean of it, which for me it came out to be 2.29. So I forgot to mention one point while taking the reading is, I have to keep in mind two things. So when you take the first trial, you got to make sure that before you start the second trial you wait for some time, and then you take the second trial, and so on. And the other thing is, make sure that your apparatus is not shaken, otherwise it affects the reading. Okay, the reason we are waiting is to make sure that the oil reaches the inside of the capacitors properly, so that there are no air bubbles kind of thing in the capacitor which might affect the readings.